Welcome to our design presentation. Today is a special day for us. Today we look back at the incredible first 2 months of Team Epoch. 2 months in which this team has evolved from a simple idea to an amazing group of 9 people working together to compete in an AI competition. So what is Team Epoch? Well, we are a team of students from different levels of education, with different backgrounds, but we have one thing in common: a big passion for AI. Together, we compete in online AI competitions with a focus on machine learning. And we do this because we believe that AI will be one of the most influential technologies in our future. And because we believe that the more people will participate in the field of AI, the more it will be beneficial to all of us in the long term. In short, it's our mission to democratize AI. And as part of this mission, we have set ourselves 3 goals. First of all, we want to build a student team that acts as a framework for students to grow as an all-round AI engineer within a team. Secondly, we want to compete in AI competitions that produce top quality AI software that makes this world a better place. And finally, we want to bring a general awareness about the possibilities and also the consequences of AI software among a very big group of people. And now, in collaboration with Jan Rellemeyer, Jan van Gemert and Arnoud Visser from the universities of Delft and Amsterdam, we have been able to achieve the goal we set ourselves for the summer: competing in the Cornell Birdsong identification competition with Team Epoch. And now we're going to tell you about our approach for this competition. So, with that, let's get started by sending it over to Delara.
The Cornell Birdsong identification is an online competition that takes place on the platform Kaggle. On this platform, there are multiple competitions to stimulate data-related and machine learning developments. The goal of our competition is to recognize and classify bird species out of recordings of natural soundscapes. Currently, this work is being done manually by bird experts. However, these analyses are slow and results are often incomplete. So this is where AI, and especially machine learning, may be able to assist. There are endless recordings of soundscapes with a wide variety of sounds, and the challenge is to use these recordings to classify birds automatically in the future. In the end, this will help us keep track of and protect the precious bird species of our planet.
We use machine learning to classify bird calls. But why exactly do we use machine learning? There are many ways of solving a problem on a computer, not all of them using machine learning. To explain our choice, I will quickly summarize the inner workings of a recurrent neural network and how this relates to birds classification. Imagine you have a data set containing 3 pieces of information: the width, the height, and also the class which each entry in the data set belongs to. A neuron, the basic building block of a recurrent neural network, in principle is a random line drawer. It randomly draws a line through our data set, dividing our data set in points above and below. If this is done perfectly, then good, we're done. Our neuron has perfectly classified all data in the data set. Usually, however, there are a few mistakes. However, our neuron is able to readjust itself little by little for each error until it approaches a good solution. Now imagine combining multiple neurons in a grand network. You have a really complex line drawing machine capable of accurately and precisely classifying large data sets. Now imagine instead of width and height, we have sound information about bird calls. Imagine we get sound information from a bird for which we don't know which class it belongs to. We can plot this sound information in our imaginary graph. Whether it's above or below the line indicates to which class of bird it belongs to.
So how do we go from this to actually classifying bird calls? Well, instead of having to manually decide what call contributes to what species of bird is calling, we use a computer. This is both very much faster and it could be very precise and accurate. However, this depends completely on the data we can use. In this competition, the training data for the competition is very different from the data we will be testing. And that means that we have to use data augmentation. Data augmentation means that we create artificial data using our original data. And this artificial data, we think, will be a better representation of the real world data we will be tested on. Let's imagine, for example, that two birds call at the same time. This will be very conflicting information for a neural network that has never seen it before. Therefore, we combine sounds from our training files. And we do this so our network can learn on that. And it can learn to recognize two bird calls at the same time. So when it's tested and actually two birds tweet at the same time, hopefully we can recognize this. So there are many situations in which our network has to deal with unfamiliar data it has not seen yet. So we apply different augmentation methods. For example, we add and remove background sounds, so our network is able to adapt to different environments. Also, we change the pitch and the loudness of bird calls. We do this to recognize different birds from different species, and we do that to recognize birds at different distances from the microphone. And we do all this to prepare our network as good as possible for all the different situations it might be facing while being tested. So during this phase, we've learned a lot about data augmentation, about the network, but most of all, about functioning as a team. We will be taking all this with us to the next phase.